Hello, my name is Anna Wadhwa, and with the support of Dr. Fernando Velloso and Dr. Stephen Levison from the Rutgers, New Jersey Medical School, we investigated the sex-dependent behavioral changes in a mouse model of autism spectrum disorder. Autism spectrum disorder, or ASD, is a neurodevelopmental disorder that is commonly diagnosed in children, and the incidence of ASD in the US has been consistently increasing, and it's especially high here in New Jersey. Now, ASD is a complex disease. There's a number of contributing factors, including genetics, maternal infections during development, and a sex bias in incidence, where males are more likely to get diagnosed with ASD. And so this, coupled with an assumption that females are simply attenuated versions of male phenotypes, has led most studies in the literature to only use male mice in their ASD models. And so that leaves females very understudied, which is why this work is specifically focusing on those sex-based differences in ASD presentation. And we're doing this using a recombinant interleukin-6 or IL-6 injection paradigm. IL-6 is a cytokine that causes neuroinflammation and impairs neural differentiation, and it's known to be elevated both prenatally during development and in children with ASD. And so we're using this already established IL-6 model in neonatal mice to mimic a maternal infection and induce transient neuroinflammation. And this will elicit the kind of social behavior deficits that are typical of neurodevelopmental disorders, including ASD. And so this is going to include things like low sociability, high anxiety, hippocampal cognitive difficulties, and other kinds of comorbidities, which is what our behavioral tasks specifically focus on. And so from postnatal days 3 through 6, we inject 75 nanograms of either the IL-6 or PBS intraperitoneally. And then starting from P7 through 8 weeks of age, we measure their weight and internal body temperature. At 9 weeks, their daily food intake. And then from there, we start our behavioral experiments. So a Barnes maze for spatial memory, an elevated plus maze, and an open field task for anxiety, and self-grooming tasks for repetitive behavior. And so in those 8 weeks of age, we see that the IL-6 injected males had lower daily food intake than the PBS males. However, this did not cause any growth delays, as we can see in both the males and the females here between the PBS and the IL-6 animals. Also, in those first 8 weeks of age, we see that there was a subtle but significant difference in the internal body temperature between the IL-6 and the PBS animals. And this was more consistent and prominent in the males as compared to the females, as you can see here. And then we got started with our behavioral experiments. And so at 10 weeks of age, we're doing the Barnes maze to test spatial memory. In this, the mouse is placed at the center of a circular maze with all these holes around it, and it's got visual cues to orient itself. And so the mouse will explore these different holes and eventually find the escape hole called a target. And we measure the time to move, so the freezing time, the time to find the target, and the number of incorrect holes or these other extraneous holes that were checked, considered the errors. We do this for 4 days, called the acquisition period, while the mouse learns where the escape hole is. And day 5 is the probe trial, and then day 12 is a memory retention trial. And what we found was that there were actually sex-dependent changes in their memory. As we can see in the males here and the females here, both of the IL-6 sexes had increases in time to finding the goal box. However, in the females, we can see that this was due to increases in their latency and in their freezing as opposed to changes in errors. They actually had less errors compared to the PBS females. And then at 11 weeks of age, we're looking at their anxiety. In an elevated plus maze, the mouse is placed at the cross section here, and we measure how much time they spend exploring the open arms compared to the closed arms. And More time in the open arms is considered a marker of decreased anxiety because they're more willing to explore their environment. And similarly, in the open field task over here, the mouse is placed in the center of a box, and more time spent exploring the inner zone compared to the outer zone closer to the walls is also a marker of decreased anxiety. And we see that in both sexes, the IL-6 animals are spending less time in the open arms, less time in the inner zone, and therefore may have slightly increased anxiety, although this was non-significant. And in the females, actually, this trend was slightly more prominent, although still non-significant. And then finally, at 17 weeks, we're measuring their self-grooming behavior as a marker of repetitive behaviors. And so during a 10-minute time period, we time their cumulative duration of time spent cleaning their paws, ears, and fur. And we see comparable increases in both sexes in self-grooming behavior. And so to recap, we used a neonatal interleukin-6 injection model to investigate the role of IL-6 and sex in ASD-associated behaviors. And what we saw was that although both sexes are performing worse in some tasks, for example, comparable increases in repetitive behaviors, in other aspects, the females are responding differently to this transient perinatal systemic inflammation that we induced. And this includes sex-dependent memory changes and possible trends towards increased anxiety. And so from that, we can see that these female neuropsychiatric behavioral deficits are not simply attenuated versions of those seen in males. And so thank you to everyone who helped support this work and who helped guide it. And thank you to you as well for listening. This poster and more information is available at tinyurl.com/CAURS-Wadhwa. Please do feel free to reach out with any questions or comments. Thank you.